Hello, in this brief video tutorial we will be discussing how to fit parametric distributions in ModelRisk. We'll be showing a number of unique and user-friendly features available in ModelRisk. If you have not already, I'd encourage you to first watch the video tutorial of an overview of fitting in ModelRisk, because there's a number of types of fitting, and watching that might help put what we're doing here into context. A quick mention on parametric distributions. What we're doing when we mention parametric distributions, what we mean are a set of distributions. They usually have some kind of a name like normal or beta or gamma, and they can be completely defined mathematically with a set of numeric parameters. And so what we're going to be doing here is imagining that we have a set of data, here in this case 1,000 samples from a larger population, and what we want to do is find the parametric distribution and the parameters that will most closely fit the data that we've selected, our sample data, so that we can try to represent the entire population within a risk analysis model. The way we do that first is we'll select the data, we go to the ModelRisk tab, we'll select the Fit button and choose Distribution Fit. We get first the distribution fitting window, which gives us a histogram of our data, maybe our first look at the actual structure of this data. We now need to choose some parametric distributions that we want to try to fit to the data. We'll go ahead and select all the continuous distributions. You'll notice a couple of them are grayed out and we were unable to select them. That's because ModelRisk has already decided or knows that these two distributions will be difficult or impossible to fit to the data that we've chosen. We click OK. In a very short few seconds, what ModelRisk does is fit all of these listed parametric distributions to our selected data. It's also calculated the closest parameters for each of those distributions and calculated some goodness of fit statistics called information criteria, which we feel like are a superior method to some of the more traditional goodness of fit statistics in determining what is the best distribution to fit the data. In this case, we're being told that the gamma distribution is the best one for our fit, and so we'll go ahead and choose that. I'll also mention that there's a parameter here we can select called uncertainty. When it's not checked, ModelRisk has fitted a gamma distribution to our data and determined that the best possible parameters are 1.9655 and 3.0394. And if we were to use this information, we would be making a very big assumption that in fact the entire population from which our samples were drawn fits with these parameters. Since we may have some uncertainty about that, we can choose the uncertainty parameter, which allows us to actually select slightly different parameters every time we run a simulation, so that we can allow for that uncertainty that we might have about how well we've been able to fit this distribution to our data. So we'll work with uncertainty. We recommend that you always select uncertainty unless you have a specific reason not to. So let's now put this distribution into our spreadsheet. We can do that in a number of different ways. We can put the actual parameters into our spreadsheet. We can actually put distributions from which we can sample in our spreadsheet. We can put objects into our spreadsheet and also percentiles. The way we do that, once we've selected the distribution and selected uncertainty, so we click the little Excel icon, and here are our choices. We'll start with parameters. ModelRisk tells us it's a 2x2 matrix, so we'll go ahead and select these two. Click OK. Click OK again. What we can see is that we've put the two parameters for the gamma distribution, the alpha and the beta, in these two cells. If we want to, in our model, we can then manually enter a distribution, the Vose gamma, which is linked then to these two parameters, so that we can then take samples from the distribution itself. However, if we hit the F9 key, what you'll see is that actually these two parameters are changing each time we recalculate the spreadsheet. That's because we had selected uncertainty before, and we're allowing for that in the parameters of the distribution, and that's reflected then every time we take a sample from the distribution. It's being reconstructed with the two new parameters, and then a sample is taken. So let's imagine we now want to just directly put into our spreadsheet the ability to take samples directly from this. What a nice feature in ModelRisk is we can go back and select these two parameters, which we had put in before. Click the View Function button. It brings back up our distribution fit window. We can this time choose the Simulate option, choose a single cell, click OK. Another option we have for sampling directly from the distribution is to select the static fitted distribution. We'll click OK again. Click OK in this window. What we now have are the ability to sample from the fitted distribution with uncertainty. And what we've entered here is the actual fitted distribution without uncertainty, with the actual parameters hard-coded into the formula. Again, if we hit F9, we're now taking samples. Again, here from our fitted distribution with uncertainty, and here from the parametric distribution, which is the closest fit. If we want to maybe start work with objects in ModelRisk, click the View function again. We want to click on the fitted distribution here, click the View function again. Select to enter an object, which we can put in this cell. Click OK. We can see now the Vose gamma object is in there. Again, if we hit F9, we'll see that the actual parameters in the fitted object change slightly, and that's because we've selected uncertainty. If we want to take a sample of this distribution object, we can do Vose Simulate, select that cell. And now again, we're sampling from this uncertain distribution. The nice thing about using objects is if we in fact wanted to take a sample of this distribution in many places in our model, we would need to only fit it in one place, put the object somewhere in, and we can refer to it from a number of other places within the model. Lastly, what we'll do is our last choice is to essentially take the inverse of the cumulative distribution. If we want to perhaps enter a percentile, in this case we're calling it a U value, I'll put in 0.5 for the 50th percentile. We'll select that cell and click OK. What this is now always going to show me is of the fitted distribution, which remember it now has uncertainty. For every iteration, it's going to find the 50th percentile of the fitted uncertain distribution. So we've shown here a number of options and ways to utilize fitting of parametric distributions within ModelRisk. Hope you found it interesting. I'd encourage you to also look for the video where we discuss the fitting of non-parametric distributions to data, as well as the fitting of copulas for various types of correlating distributions. So we can fit distributions to data, perhaps multiple distributions to sets of data, and then also fit a correlation structure, combine them all quite easily in ModelRisk. So please look for that video as well. If you'd like to find out more about ModelRisk, and you have not already, I'd encourage you to download a free trial, 30-day fully functional version of ModelRisk from www.vosesoftware.com. There's also a number of good resources in the ModelRisk help file, which is also available on the Vose Software website. You might be interested in contacting our sister company, who's also our main reseller, with sales or technical questions or questions about consulting, at these numbers or at www.voseconsulting.com.